Hello and welcome to our presentation. My name is Marcin Lewandowski and I am the CEO of the us4us company. I would like to introduce you to our ultrasound research platforms as well as technology and application offered by us4us. We are a relatively young company established back in 2015. Just a few words about our ultrasound technology. This is a traditional three-stage ultrasound processing pipeline and technical means applied to digital processing. In classical approach, the first two stages, the modulation and beamforming, are done mainly in hardware using FPGA or ASIC. Only the backend is usually done in software. Our solution, GPU-oriented, are optimized for full software processing. This is so-called software-defined ultrasound or SDU. We are acquiring and executing software processing from the very beginning. We can work on demodulated data like AQ data or directly on raw radio frequency data before demodulation. To enable this, we need a high-speed data flow and massively parallel processing, for example, GPU. So how those two approaches compare? Classical versus software-defined ultrasound. Traditional delay and sum beamforming is a workhorse of ultrasound imaging. In this approach, radio frequency data from each and every element of the probe is processed on the fly by a piece of hardware and forgotten. So radio frequency data is not stored. Data is delayed and summed to create scan lines. In software-defined ultrasound, on the other hand, full radio frequency data from all the elements of the probe are digitized and stored in memory. Thus, it is available for advanced software processing, including multi-step and retrospective algorithm. All the processing is done in software. It enables application of advanced synthetic aperture focusing techniques and other techniques that works on ultrafast and plane wave methods. Software-defined ultrasound is really needed for application of ultrafast ultrasonic imaging. Ultrafast dataset can be exploited and processed by various algorithms to enable a true multimodal imaging. From a single ultrafast dataset, we can extract information on anatomy, like traditional B-mode imaging, on blood motion, using, for example, Doppler processing, on tissue motion, for example, elastography, on microbubbles and super-resolution imaging, as well as functional ultrasound. And now about our products. I would like to start with our portable ultrasound research platform, us4us Lite. It is the smallest device on the market featuring software-defined ultrasound and ultrafast plane wave acquisition and supporting probes up to 256 elements. It is thanks to 256 transmit channels and 64 receive channels. The system can be connected to external computer using Thunderbolt interface and enabling real-time streaming of raw radio frequency data. The system can work as a PC peripheral when processing is executed on external PC or in standalone mode with an optional NVIDIA Tegra processor. The system is fully programmable with our software development kit supporting C, C++, Python, and MATLAB. On the high end, there is our advanced ultrasound research platform, us4us, featuring 256 receive channel and up to 1000 discrete transmit channels. The device can support both 2D and 3D imaging. Thanks to 1000 transmit channel, the system can accommodate a fully wide 32 by 32 matrix array probe. It provides a massive data bandwidth of raw radio frequency data up to 25 gigabytes of data per second, making it the fastest on the market. The very same API and SDK is available for this machine. Last but not least, us4OEM. It is a highly integrated ultrasound front-end module that is used in our own ultrasound research systems. We are offering the module exclusively for serial production of end-user equipment, both medical and industrial. We also support its integration and development of novel scanner based on this technology. A bird's eye view on the us SDK that support all our ultrasound solutions. The SDK is open source framework for programming ultrasound platforms and acquiring raw radiofrequency data. The us SDK can be easily integrated with various parallel processing APIs, in particular NVIDIA, CUDA, OpenCL, OneAPI, and more. Currently, we support Microsoft Windows, and we have an early Linux version. And just a few selected applications of our platforms. As a part of currently running R&D project, an open research ultrasound platform for real-time 3D imaging, we are preparing and developing our us4us platform to support 2D and 3D imaging. A dedicated hybrid spectral domain synthetic aperture imaging reconstruction method will be applied. The system is well suited for acquiring mixed 2D and 3D dataset, for example, in ultrafast functional imaging. Here you can see our system connected to 32 by 32 fully wired matrix array probe from Vermont. And here is one of our latest development, an integration of the us4us light scanner with NVIDIA Clara AGX. Clara AGX is the newest NVIDIA AI workstation target for implementation of AI in healthcare. It features an embedded Jetson AGX Xavier and high-performance RTX 6000 GPU. There is an IUS presentation about this solution. Please look for my name in the program. Our scanners used to work with desktop GPU from the very beginning. Now we are working on even tighter integration with a full range of NVIDIA GPUs, including embedded system on chip. This development will enable extending application of software-defined ultrasound to a full spectrum of ultrasound imagers. NVIDIA supplied software libraries make it feasible to integrate both classical ultrasound digital signal processing, deep learning, and visualization on a single GPU. This is a great opportunity for building in-the-file upgradable and extensible ultrasound solution. Thank you for your time, and please contact us. For sales inquiries in China mainland, you can contact our local distributor.